Morning, everyone. Thank you for the introduction. My name is Tony Ibanez. Today, I'm here to talk about agentic AI, multi-source fusion, and the hidden strain on analytical infrastructure. So, a little bit about me. I'm a senior solutions architect at Ocient National Security Solutions. We are the official, public sector global vertical of Ocient, which is a software company headquartered out of Chicago. I've been in my current role for 4 years, but overall, I've got roughly a 20-year career taking care of federal government end users. This means architecting, selling, installing, supporting really large and high performance data storage and processing systems. I've worked with Department of War agencies, IC agencies, and civilian agencies. So I've done a little bit of everything in that time. And you can see some of the companies that I've worked for in the past up there. So with that, let's get into the talk. It's funny when you talk about AI, it feels hard to talk about the current state of the art because everything is evolving so much. So really, with AI and with agentic AI in particular, it's kind of a journey that everybody's on together. So I want to talk about the journey that agentic AI is kind of forcing on everybody who does large scale data processing. We're going to talk about some of the changes in analytic workflows that are introduced with AI agents, what that means for your analytic layer. It does create a little bit of strain that is not immediately apparent. So we're going to characterize that and talk about where that comes from. We're going to talk about some of the usual remedies that people talk about that are essential when you're introducing agentic AI into, data workflows, and why some of them don't always fix this hidden strain on the infrastructure. Then we're going to take a closer look at fragmented analytic stacks where you have multiple products doing different types of analytics. And then we're going to talk about architecting for the future. How do we build for agents to, anticipate the challenges that they'll impose on environments, and what does good look like in the future? So let's first talk about the shift, right? So if we think about the way data analytics was performed in the past, it was primarily a human-paced workflow, right? So a human analyst would think about a business question that needs to be answered. They would create queries one at a time, typically by hand. They would issue those queries against backend systems. They would get partial results back. They would apply some judgment to those results, potentially issue subsequent queries. But at the end of the day, the human analyst would decide when the answer was good enough to answer, the business question. And all of this pacing kind of naturally throttled the, demand on the backend systems. So if we move from that to an agentic focus, right, we're now moving at machine pace for everything, right? So that human pacing is totally gone from the workflow. And an AI agent can decompose an objective autonomously. It kind of figures out what's the best way to answer this question, possibly pursues multiple theories for how to answer the question in parallel. Each one that comes with its own set of queries will validate the assumptions, then refine, and then repeat, and do this again and again until it's satisfied. And the agent, in and of itself, has no inherent sense of what the cost it's imposing on the backend infrastructure is, or when the answer is good enough, right? So the move towards an AI-based agent for data analytics means that we're getting real productivity gains, but they do come at the expense of a significant workload increase on the backend systems. Fundamentally, what does this mean? That means one question that you ask to an agent turns into many requests on your backend systems, right? So the way agents work through problems is, inherently exploratory, and it's iterative and non-deterministic. You can't know going in exactly how the agent's going to break down the question. So starting with decomposition, right? You take a natural language query, the agent's going to figure out how to turn that into sub-questions that need to be answered, and each sub-question will have its own query that accompanies it. Then there's an iteration phase where each partial result of those queries that it's pursuing is going to feed the next round of questions and the next round of questions. And the agent basically keeps going until it's satisfied. And it can pursue multiple hypotheses in parallel, right? So multiple queries running simultaneously before any of them are pruned, and it decides, well, maybe that hypothesis wasn't correct, and moves on with the end, right? We've seen some anecdotal evidence in our labs that on certain types of infrastructures, one analyst type question that's issued in natural language can break down into as many as 40 independent queries on backend systems. So that is a significant workload amplification. It's not wasted effort, so that's important to remember. But the question is whether the infrastructure on the backend was built to support it and expects that kind of workload amplification. When we talk about agentic, there's typical fixes that we hear about a lot: semantic layers, data governance, and possibly specialized data engines as well. each one of which helps with a different facet of the problem, but it doesn't fundamentally address the problem of workload amplification, right? So semantic layers, they're pretty critical because they do help agents understand the business context and the meaning of the data rather than try to guess at what that may be. So they give them consistent and meaningful, definitions of terms to work with. But clear question is still one of many, right? So it doesn't limit the volume of queries on the back end. Data governance is another key facet here. When we have human beings working with an agent that autonomously can access these backend systems, we need to make sure that we're limiting access appropriate to the privileges of the person who's asking the question. So data governance platforms help with that. They also help maintain an intact data lineage so you know where your answer came from and can reproduce it. But again, that doesn't govern how many queries are issued, or it doesn't do anything to pace the machine flow of the query workload. And then lastly, specialized engines. They can help with different pieces of analytics. And I'm thinking specifically about workflows that require things like historical analysis combined with real-time analysis, combined with maybe machine learning or geospatial and things like that. And so there are products that address each one of those categories separately. But this kind of introduces a different problem, which is when you have a query workload that fans out among those, you're introducing even more workload amplification, and we'll talk about that next. So when you're fragmented among different types of analytic stacks, you have an ongoing tax on your analytic infrastructure and in the agent workflow itself. Think about, historical analytics, real-time, geospatial, graph analytics. You could frequently have to, address these different types of data and these different analytic workflows by asking a single question or a single series of questions. But whenever the agent has to cross over from one platform to a next, you're basically causing the agent to carry over partial results and do a join against those results in its context window. And you're causing that agent to consume more tokens to essentially orchestrate workflow among the different platforms. And that basically imposes a tax on your ongoing analytics, and it's only going to get worse over time as you continue to pay that orchestration tax. So what we think is a better approach here is a consolidated analytics platform that is capable of doing more of the types of analytics that your workflow needs in one platform. So ideally something that can do both your historical analytics combined with real-time, if geospatial, if you need it, and graph analytics evaluated together in one place. That orchestration tax of having to do joins in the token window, the context window of the agent, basically goes away. So, moving into the future, what are some principles that we can follow to build for an agentic future and stay mission ready? The first that we would recommend is to make the cost and contention caused by these agents visible. Do everything that you can to surface, the system level constraints and make those visible to the agents so that the workflow can actually add some pacing to the engine, can maybe optimize its queries and so forth so that it's more efficient with the cycles that it's consuming on the back end. The second, where possible, we would recommend consolidating the analytical surface, using fewer systems that are capable of processing more different, analytic workflows rather than specialized engines for, different types of analytics with the same data effectively in multiple places. The third, make sure that data governance is built in and make sure that it's capable of running at machine speed. Data access, lineage, and policy enforcement are really, really critical here. And we want to make sure that they're built for autonomous actors, not just for human access control. And then lastly, you want to treat agents and their workloads as a first-class workload within the system. Make sure you're budgeting system cycles, prioritize their work, make sure that you're using whatever workload management policies that your engines provide you to make sure that the agents have the performance that they need to do the critical work that is going to be expected of them in the future. So, with all that said, where is Ocient in all of this, right? So as I mentioned before, I've been with this company for 4 years. And what I'm seeing is it looks to us as if we're in the perfect place at the right time. From our founding in 2016, we're basically a mature startup at this point, having been founded in 2016. And our company was founded on the principle of basically being able to ingest, index, store, and analyze the world's largest data sets and give meaningful results to those in interactive time. We started off as basically a hyperscale SQL compliant data warehouse built for historical analytic use cases. And since I've been here, we've added real-time analytics to our bag of tricks. We've added machine learning, we've added vector-based geospatial analytics, and now graph analytics to the platform. And combined with the speed and scale of which the platform is already capable, we think this puts us in a really, really good spot to push the analytic frontier forward with agentic AI. We are a Chicago-based company, and we're an In-Q-Tel portfolio company. For those who don't know, In-Q-Tel is the venture capital arm of the U.S. intelligence community. So that's a nice little backing to have for a startup such as ours. We are also available on the Tradewinds AI marketplace from the Department of War, as well as NASA SOUP and Army ITES. And when it comes to the agentic future, we just recently announced Ocient AIQ, our unified data platform. So what this is it's a combination of the hyperscale data engine that we've always had, that's inclusive of data ETL, offers all those types of analytics with a number of optimizations that are built for an agentic future. Starting with data ingest, right? We are capable of ingesting data, structured, semi-structured data at essentially arbitrary scale. We've built a scalable engine there that allows us to ingest, terabits of data per second, hundreds of millions of rows per second, whatever the client needs, we can build it for them and make sure that query performance doesn't degrade during heavy loading. The second is we've built a robust data governance platform into the product itself. Full data access controls, lineage, and policy enforcement built directly into the product. The agent intelligence engine, as I mentioned before, combines our ability in natural language SQL to do historical analytics, real-time analytics, full machine learning, vector geospatial, and graph analytics as well, and with reproducible answers that you can rely on when you need to access trillions of records and get real results in interactive time. We also are providing a full business context with machine-readable ontologies for all the data that's built directly into the platform itself, so that agents can reason on the meaning of the data rather than try to guess at it. We're also packaging skills that inform the agents of, what power is available within the Ocient platform. We tell it how to properly query against us. We can recommend throttling where necessary, but we don't think that's really necessary in most cases. But we can, make sure that the agents do more effective work and fewer wasted queries. And then lastly, we have full workload visibility and workload management built into the platform, so we can guarantee that the agentic workflow gets the performance that it needs without being disrupted by other workflows that may be happening in a multi-tenant environment. And, out of scope for this conversation, some of the key intellectual property that's built into the platform is listed at the bottom there. There's been a lot of innovation in this platform over the last 10 years that we're very proud of.